In this video, we're going to be taking a look at a mass suspended in an electric field. We have one problem. We're going to find the charge and whether it's positive or negative. And then the second one, we're going to solve for the magnitude of the electric field and the direction in which it's pointing. So for our first problem, we have an object that has a mass of 12 grams and it's suspended in an electric field. So we have two forces on it, which are the force of gravity, and then that force from the electric field must be counteracting it, or else it wouldn't be suspended at rest, which means the net force on the object is definitely zero. So since we know that the net force is zero, that means that the force from the electric field upwards minus the force of gravity downwards is going to equal 0 newtons. So if we go ahead and add Fg to both sides, that means that those two forces are equivalent to each other. So if we go ahead and plug in those values, we know that the electric force is QE. We're looking for Q, so we don't have that. We're going to plug in our E, which is 5,000 newtons per coulomb, equals our force of gravity, which is mg. For our mg, we have a mass of 12 grams, which translates to 0.012 kilograms after you divide it by 1,000. So we have 0.012 kilograms times our constant of 9.8. And then we can go ahead and divide each side by 5,000. And then we have our value of Q, which comes out to 2.4 times 10 to the negative fifth power in coulombs. Now we want to figure out whether that Q is a positive or negative value. This is really just giving us the magnitude of the charge. Now, if the object is being pushed upwards against the electric field, that means it is a negative Q value because the electric field is the direction that a positive test charge follows. So if it is getting pushed up in the opposite direction, that means the Q is negative. So our final answer is going to be negative 2.4 times 10 to the negative fifth coulombs. Now let's go ahead and take a look at our second problem. Our second problem is fairly similar, but we do not know what the electric field is and which direction it's pointing, but the setup is going to be fairly similar. It's going to look like this. All right, now we have everything all set up. We know that the electric force is equal to the force of gravity because if the object is suspended at rest, those two are going to cancel each other out and have a net force of zero. This time we have a Q value, but we do not have our E value. And then on the right side, we still have the same values for our mg. So we're going to divide both sides by 30 microcoulombs. So I changed the 30 microcoulombs to 30 times 10 to the negative sixth, which is the exact same thing. So we're going to go ahead and divide both sides by that 30 microcoulombs. And then we have a value of 3,920 newtons per coulomb. So we know how much force is applied per coulomb of charge, and that's the magnitude of our electric field. Now we know that mg is pointing downwards, so we need a force that is going upwards. So if the Q value is positive to begin with, it doesn't have to have a plus sign in front of it, but if there's no negative sign, we can assume that it's positive. So if it's a positive Q value and we have an electric field that's forcing it upwards, then the electric field must be upwards so that the positive charge will follow that electric field and counteract the force of gravity. So now we have our answer. We have 3,920 newtons per coulomb directed upwards because it's a positive charge following those lines to counteract the force of gravity. So to sum things up, if you take a look at each one of these problems, if it's an object that is suspended in a field, that means the force of gravity and the electric force are equal. The net force is zero, so you can set those two equal to each other. Oftentimes you'll use the formula QE, as we did right over here, and then secondly over here as well. Um, and then obviously mg for our FG formula. Once you set those two equal to each other, you put in your known values and solve for your unknown value to get your final solution. So I hope that was helpful to you. Thank you for watching and listening.